All right, so now we're going to kind of transition into the other part to this unit, and that is looking at the types of chemical reactions. Before I do that, though, I need to lay a foundation for one of the types of reactions, and that deals with when chemical reactions are done in aqueous solutions. Um, and what that basically means is that we have some sort of reactant or solute dissolved in water. Now, the other aspect to this is looking at a property of a solute that's known as solubility. Solubility basically asks, does it dissolve in water? If it partially does, or if it all dissolves, and the answer is yes, we say that it's soluble. If the answer is no, then we say it's insoluble. Now, for example, let's take sodium chloride, table salt, and let's put it in water. Now, sodium chloride is known as a strong electrolyte. I'll go deeper into that much later. But strong electrolytes fully dissociate, they fully dissolve in water. And what I mean by dissociate is that they separate into their ions, sodium cations and chloride anions. So think about this. If we take a glass of water and we put some table salt in that water and stir it up, then the sodium chloride dissolves into sodium ions and chloride ions, and they just float around, but they are no longer ionically bond to each other. Now, the reason they call this a strong electrolyte is that because it conducts electricity. And this is something that you don't have to know that for right now. I'll go into that later. But, this is why you never want to swim in a pool during a lightning storm because there's a lot of electrolytes in the pool and that those things will conduct electricity very well. So we would say this is soluble. Now, what does something insoluble look like when you put it into water? Again, got a glass of water here, and I'm going to put some silver chloride in the water, and I'm going to stir it up. And what you'll notice is that it just kind of doesn't dissolve. It's insoluble. Now, one of the skills you need to develop is being able to predict, how do I know if a solute is soluble? And right now I'm going to focus just on ionic compounds. So you're going to use this chart, and I'm going to provide this for you. So I don't expect you to memorize anything. I expect you to know how to use this chart. And what this chart says is that in the upper half here, these things are soluble if they contain this ion, and then there's some exceptions. And then at the bottom, it says these things are insoluble, but here are the exceptions. So for example, sodium chloride, NaCl. Okay, so I'm going to go look at the table and notice that on the ions there is the sodium cation. And there aren't any exceptions. So since there's sodium present, um, this is soluble. Now let's look at another one, calcium carbonate. All right, so I'm going to look at my, I can't find calcium anywhere on this table, but I do see carbonate. And carbonate is down there in the green. It says compounds containing these ions are mostly insoluble and except soluble when paired with lithium, sodium, potassium, ammonium. Well, this carbonate's not paired with any of those. So calcium carbonate is not soluble. And then finally, let's look at silver bromide. I look at the table and up in yellow there, bromide is on the list. Bromide is in the list that says compounds containing these ions are mostly soluble. But what are the exceptions? The exception is insoluble when paired with silver, mercury, or lead. Since this bromide is paired with silver, it is insoluble. So as I said before, I will give you this table, but you need to know how to use it and be able to predict if if an ionic compound is going to be soluble or not in water. And when we get into the next video, we'll see why this is important when we're describing a certain type of chemical reaction.